All right, so we're going to do a little bit of quick review of what we did yesterday, and then we'll extend on what we talked about yesterday. Yesterday's theme was on solving square and cubic equations like this. A reminder that whenever we're solving equations like this, we want to get the variable squared or cubed by itself. In this case, we wanted to divide both sides by 5. And typically, if after we take the square root or the cube root of both sides, we need to simplify whatever the root is. In this case, we end up with square root of 600, which can be simplified. And remember, on variable squared equations, both the positive and the negative version of it will work. And so in this one, we ended up with plus or minus 10 square roots of 6. And then we did another one where we had a cubic function, and we want to make sure we get the f cubed by itself by dividing both sides by 1.6. And then to get f by itself, we took the cube root of both sides. In this one, 64 is a perfect cube. And I keep putting check because mentally you should be checking just to make sure that that works. And then we did these three problems right here. And we do have to be aware that sometimes, like all year long when we solve equations, sometimes we end up with equations that have no solution. Then we went ahead and got started on these geometric shapes where I gave you the volume and you had to find the radius. And so the first thing we have to do is a quick reminder of what these formulas are. And then we substitute in the pieces that were given, and then we just have to use a little bit of math to get r squared, in this case, by itself. And since we're talking about the radius, negative radius does not make any sense. And so we end up with a radius of 5 feet in this one. Okay, and then we did a second problem, this time a sphere, where I gave you the volume and you once again had to find the radius. This is the formula for the volume of a sphere, and most of these formulas have been in the X problem packets all year long. So we plug in the important information from the original problem. We solve for r cubed. And there seemed to be a little bit of an issue yesterday about multiplying both sides by 3. So I need to talk about that a little bit to make sure there's no confusion on how this right here turns into this right here. So we'll talk about that in just a second. But we get this down to r cubed by itself and then take the cube root of both sides. And in this problem from yesterday, we ended up with a radius of 6. So clearing up the idea of multiplying both sides by 3. So if I take this, which was from the last problem, and I multiplied both sides by 3, there seemed to be some issues on how it turned into that. Well, I'm going to take a different example. This right here. What is the left-hand side of that equation? That's not a trick question. What is it? What is it? It's 24, right? So if you multiply both sides of that equation, and I'll just do it by 3 since that's what we were doing. If we multiply both sides of this equation by 3, and by the way, you just told me that it was this. What does that now turn into? What? 72 equals 3x, right? We didn't multiply the 2 by 3 and the 3 by 3 and the 4 by 3. You just multiplied that whole thing by 3. Well, that's the same exact thing that's happening right here. We have 4/3 times 3.14 times r cubed. Since it's a product, it's really just one item. So when you multiply that whole side by 3, you're multiplying the whole thing by 3, just like I did right here to get 72. So don't think you have to multiply each individual piece if it's straight multiplication. And when I do that, that's how we turned into, which would have been 12.56, but that's how that turned into that right there. So don't multiply each individual piece, okay? All right, so here is a new problem. You just need to copy down whatever you feel like you need to copy down. The volume of the sphere below is 3,052.08 cubic centimeters. What is the length of the radius of the sphere? And I'll give you the formula one more time. For the volume of a sphere, it's V equals 4/3 pi r cubed. And all of those geometric formulas we are going to have to get memorized within the next 6 weeks. All right, I want you to find the radius of that sphere. All right, so we plug in our important information, the fact that pi is 3.14 and the fact that we know what the volume is. From there, I'm going to multiply both sides by 3. We already talked about how that works. So that gives me this. And then 4 times 3.14 is 12.56. And then I need to divide both sides by 12.56, which gives me r cubed equals 729. Take the cube root on both sides. Make sure you show that step. And that would give us a radius of 9 centimeters. Any questions on that problem? All right, next one. Number 13, the volume of the cylinder below is 401.92 cubic meters, and the height is 8 meters. What is the length of the radius? And it says sphere right there. I forgot to change that. This should actually be cylinder. Okay, but I guess you need the formula for a cylinder, which is this. We usually see it as volume equals the area of the base times the height. The base is a circle. That's where the pi r squared comes from. Find the radius, please. All right, so we substitute in our important information, like the volume, like pi, and like the fact that the height is 8. From there, I multiplied 3.14 times 8, and then divided both sides by 25.12 to get r squared by itself. And we can see that the radius has to be, after taking the square root on both sides of our equation, it is 4 meters. One more problem. The surface area of the sphere below is 1,519 square inches. What is the length of the radius of the sphere? The formula for the surface area of a sphere is 4 pi r squared. Find the radius, please. We substitute in our important information. And multiply 4 times 3.14, then divide both sides by 12.56 to get r squared by itself. And then, of course, take the square root of both sides, and we end up with 11 inches for the radius. So hopefully, if that was a bit of an issue yesterday, we've cleared up everything. And that is it for today.